Hello guys, welcome to my channel. Hope you all are doing good. It's a day number 2 in 7 days coding series.
The next program is to verify whether a number is prime number or not. So before writing up the code, let's have a quick understand over the prime number. As we all know, prime number is a positive integer which is divisible by 1 or itself only, or else you can say number those are having divisors value 1 or itself. Yeah, simple as it. So here I can write it as write a Java program to check whether a number is prime number or not. So let's begin by our entry point, which is a main method, as I have said in the previous video. By writing the main and clicking on the control key and the space bar, it will auto provide the main method, and here we can initialize a variable n, a number, and we can give its value as 11. Let's say we have to verify whether a number 11 is a prime number or not, and next we will initialize one more variable named count as 0. Later I'll tell its significance, the line number 7, why I have considered this or initialized this count as 0. Alright, to check whether a number 11 is a prime number or not, so let's start. For control and spacebar, we'll use the for loop here, like this, where it will start from 2 and it will iterate till less than equal to n by 2. I'll explain why I've considered this condition, and in this I'm going to write one more condition. If n modulus operator 5 I is equal to 0, in this we can write count plus plus. Simple. So guys, let's iterate this line of code. So let's quickly understand the difference between these two operators. Basically in Java, the both operators are used to calculate the mathematical operations, as this symbol is used for division operator and this symbol is used for the modulus operator. Let's understand what this calculates and let's understand what this calculates. In this division operator, we are only concerned about this quotient part. It will give the result 5 after performing this division operator. And in this modulus operator, we are concerned about the remainder part. It will give the value 1 by performing this modulus operator action. So in short, it will give you the quotient of a division operator, and this modulus operator will give you remainder of division operator. So this is a for loop that starts with the value I, which is equal to 2. Since 2 is the smallest prime number, so it will start from this and it will iterate up to n by 2. It is also used to check the factors of n. The loop will go through all the integers value from 2 to n by 2. Then why I have taken here the value I is less than equal to n by 2? Why not I is less than equal to n? Why I am taking here I is less than equal to n by 2? The reason behind it is called optimization. The key insight here is that you don't need to check factors larger than the square root of a number n. If n has a factor greater than n by 2, then it must also have a corresponding factors follow than n by 2. Therefore, you can easily limit the range to 2 n by 2 without missing any potential factors. So that's the reason I'm writing here to limit the iteration to n by 2 rather than n. Or you can say to avoid the unnecessary iterations, you can use this condition I is less than equal to n by 2. So let's iterate it. I, when I is equal to 2, here I is equal to 2, it will check the value 2 is less than equal to 5. Yes, the condition is satisfies here. So it will enter into this for loop. It will enter into this for loop. And again one more condition is here. From here it will check whether n, which is 11, modulus operator I, which is 2, is equal to 0. No, because it gives, this operation gives us the remainder value as 1, which is not equal to 0. So we can say it is not equal to 0. Alright. Again, it will not enter into this if loop because the condition does not satisfy here. It will go back to the for loop. Here it will raise the value of I by 1. Now the value of I will be equal to 3. Now I, which is 3, is less than or equal to 5. True, the condition satisfies here. It will enter into the for loop. Again it will check the if condition where 11 modulus of 3 is also not equal to 0. Condition false here. It will not enter into the if loop. It will go back to the for loop again. It will check now. After following the condition here, the condition false here, so it will go back to the for loop and raise the value of I by 1. So the value of I will be equal to 4, which is less than or equal to 5. Condition satisfied here. Again it will enter into the for loop and check here whether the 4 modulus of I is equal to 0 or not. So here we can say 11 modulus operator of 4, which is also not equal to 0. Again the condition fails here. It will go back to the for loop. It will raise the value of I by 1, which is equal to 5 now. 5 is either less than or equal to 5. Condition satisfies here. It will get into the loop and check whether 11 modulus of operator 5, will it give us the value 0? No, it will not. 0. The condition fails here. Again it will go back to the for loop and check. Before checking, it will raise the value of I by 1. Now the value of I will be 6, which is less than or equal to 5. Now can you say 6 is either less than or equal to 5? No, the condition falls here. It will terminate this for loop, and now we can write a code as if count is equal to 0, then only it will enter into this loop and say the shortcut for system.print system dot the shortcut for SYSO will give us system.out.println. Here we can say the given number n is a prime number. Okay. When the value of count is equal to 0, then only it will enter into this and say the given value, the given number, that is 11 or whatever, is a prime number. If the condition fails here, it will come into the else path and say it is not a prime number. The given number n is not a prime number. So shall we check? So by running here, we can check. The given number 11 is a prime number. Can we check this for another number, say 10? Yes, we can. Let's see the result. The given number 10 is not a prime number. Since 10 has factors more than 1 or itself, that is 2 and 5 is also its factor. So 10 is not a prime number. So for the similar way, we can check for another values as well. The number is not a prime number. For values like this, we can check the number is not a prime number. 17. Can we check? This number is a prime number.
So guys, you can practice further in a similar manner. Thanks for watching. Bye bye. Take care.